හරි පුතේ. එතකොට අපි 9 question number 19 වලින් ඉඳන් පටන් ගමු හොඳේ. මෙතනින් එහාට තමයි අනිත් ටික ලේසි අර නිකන් formula application එක තමයි තියෙන්නේ. ඔතනට එනකම්. මෙතනින් එහාට ලේසි. හරිද? right. අපි question number 19 වලින් ඉඳන් discuss කරන් යන්. මේකේ අන්තිම ටික වෙනකොට ටිකක් හොඳ ප්‍රශ්න ටිකක් අමාරු ටිකක් තියෙනවා. ඒ ටික හදා ගන්න පුළුවන් නම් හොඳයි හොඳේ. අපි discuss කරන් යමු. right. So, question number 19. A cutter rotates from rest at a rotational frequency of 50 Hz in 10 seconds. Find its angular velocity. First thing. And එතකොට දීලා තියෙන්නේ මොනවාද? So, given two of the things, frequency, right, and time. 10 seconds කියලා දීලා තියෙනවා. First question එක කියන්නේ find its final angular velocity. හරිද? එතකොට final angular velocity හොයන්න ඔයාට දාන්න පුළුවන් omega equals 2 pi f වගේ එකක් දාන්න පුළුවන් නේ. මොකද ඔයාට දීලා තියෙන්නේ hertz ගානයි. ඔයාට දීලා තියෙන්නේ hertz ගානයි time එකයි විතරයිනේ. question number 19. yes ඔයාට දීලා තියෙන්නේ hertz ගානයි time එකයි විතරයි. तर hertz ගාන දීලා තියෙනවා නම් ඔයාට 2πf දැම්මනම් angular velocity එක හොයාගන්න පුළුවන්. ඒතර එන්නේ 2π 50 hertz කියලා තියෙන්නේ. ඒ කියන්නේ 100π rads per second. මේක decimals වලින් තියෙනවා නම් හොඳයි essay questions වලදී. මම දැනට simplify කරන්න නැතුව මෙහෙම තියනවා. හරි? rads per second. තමයි එන්නේ ඒතර angular velocity එක first question. 2πf. right. දෙවෙනි එකෙන් අහනවා find the tangential velocity at maximum angular velocity. එතකොට maximum angular velocity එකේදී tangential velocity එක අහනවා. එතකොට radius එක දීලා තියෙන්න ඕන. හරිද? මේක radius එක දීලා නැහැ. හරි? radius එක නැතුව හොයන්න බෑ. ඒව හදා ගන්න 1 meter කියලා ගන්න radius එක. හරි? radius 1 meter කියලා ගන්න. එතකොට අපි දන්නවා equation එක මොකද්ද? ඔයාට tangential velocity එක හොයන්න කිව්වම පස්සේ දාන්න ඕන v equals r omega නේ. v equals r omega දාන්න ඕන. එතකොට radius එක 1 meter omega එනවා 100 කියලා. එතකොට එන්නේ 100 meters per second කියලා තමයි එන්නේ tangential velocity එක මෙයා. right? Tangential velocity is 105 meters per second. Third one, find the angular acceleration. right? angular acceleration එක හොයාගන්න. හරිද? angular acceleration එක හොයාගන්න ඔයාට දාන්න වෙනවා මොකක් හරි equation එකක් acceleration එක තියෙන. හරිද? ඒතර acceleration equal වෙන්නේ omega t minus omega naught over time කියන එක තමයි angular acceleration එකට equal වෙන්නේ. හරිද? එතකොට omega t කියන්නේ final angular velocity, omega naught කියන්නේ initial angular velocity divide by time වලින් ඔයාලට හම්බ වෙනවා මොකද්ද? angular acceleration. So in that case ඔයාලට time එක තියෙනවා. කියන මේකේ ඊට පස්සේ question එක කියනවා cutter rotates from rest. ඒ කියන්නේ rotate එක start වෙන්නේ rest එකකින්. ඒ කියන්නේ initial angular velocity එක 0. හරි? initial angular velocity එක 0. तर හොයන්න ඕන acceleration final angular velocity එක 100 initial එක 0 time එක 10 seconds. එයාට එනවා එතකොට acceleration එක කීයද 10 rad per square second කියලා එනවා. හරිද? 10 rad per square second. මේක 5 එක simplify කරලා decimals වලට හදා ගන්න. හොඳයි. 5 එක simplify කරලා decimals වලට හදා ගන්න. Next question, find the linear acceleration. හරිද? linear acceleration එක හොයන්නලු. එතකොට linear acceleration එක වාට equation එක මතකයි a equals r alpha. ඔයාට alpha තියෙන හින්දා radius එක දන්න හින්දා linear acceleration එක හොයන්න පුළුවන්. a equals r එකට එන්නේ එතකොට 1 meter into alpha 10 phi. එතකොට එනවා 10 meter per square second of a linear acceleration. මේක 5 simplify කරලා decimals වලින් දාගන්න. හරි. එතකොට 10 meters per square second තමයි එන්නේ. Right. Next question 5. Find the angular displacement. Right. Find the angular displacement. So to find the angular displacement ඔයාට තව ෆෝමියුලා එකක් දාන්න වෙනවා. හරිද? තව ෆෝමියුලා එකක් දාන්න වෙනවා. එතකොට angular displacement තියෙන ෆෝමියුලා එකක් දාමු. හරි. angular displacement කියන්නේ θ නේ. මෙහෙම equation එකක් තිබ්බ මතකද? θ equals omega naught plus omega t divide by 2 into t කියලා equation එකක් තිබ්බා. හරි. මේ equation එකෙන් අපිට ගන්න පුළුවන්. එතකොට initial angular velocity එක 0, final angular velocity එක 100 105 divide by 2 multiplied by time spent is 10 seconds. හරි. එතකොට මේක 5 එතරාට එනවා 505 radians කියලා. හරි. 505 radians කියලා එනවා. මොකක්ද? angular displacement එක. හරි. මේ තමයි angular displacement එක. ඔයාට මේකෙන් rotations ගන්න revolutions ගන්න හොයන්න කිව්වොත් හරිද? revolutions ගන්න හොයන්න කිව්වොත් මේ තියෙන angular displacement එක radians වලින් අපි දන්නවා revolutions ගන්න හොයන්න කිව්වොත් one revolution නැත්නම් one rotation කියලා කියන්නේ 2π වලට radians වලින් radian 2π කියලා කියන්නේ one rotation කියන එක. ඒතකොට මේක 2π වලින් divide කරොත් ඔයාට complete revolutions ගන්න එනවා. number of revolutions එනවා. හරි. එහෙම කරන්න පුළුවන්. Right. Next question 20. When a roller coaster is started, it reaches a rotational speed of 120 rpm in 6 seconds from the rest. Right? Okay. So find the final angular velocity. Now you are given the rpm. rpm එක දීලා තියෙනවා. If you are given the rpm, from the rpm you can find the frequency, right? From the rpm you can find the frequency, and if you have the frequency you can find the angular velocity as well, right? ඔයාට දීලා තියෙනවානේ rpm එක. rpm එකෙන් frequency හොයන්න පුළුවන් කොහොමද? rpm divided by 60 is rps, which is the frequency, and if you have the frequency, by applying 2πf you can find the angular velocity as well, right? හරි. එතකොට ඒක තමයි angular velocity එකට එන්නේ 2πf. එතකොට 120 rpm. හරි. right. එතකොට frequency එක equal වෙනවා 120 divided by 60. That is 2 hertz. 2 hertz කියලා එනවා frequency එක. ආට frequency එක පාවිච්චි කරලා හොයන්න පුළුවන් මොකද්ද? angular velocity එක omega equals 2π f දාලා. එතකොට 2π f is 2, that is 4π rad per second, radians per second angular velocity again. Right? That is the first question. Right. Second question, find the angular acceleration. Right. Find the find the final angular velocity. Second is find the angular acceleration, right? Find the angular acceleration. So you know the final velocity, and it says when a roller coaster is started, it reaches a rotational speed of 120 rpm in 6 seconds from the rest. So it starts from the rest, which means the initial angular velocity is 0, right? Initial angular velocity is 0. We found the final angular velocity, and the time spent is actually 6 seconds for that. So using those information you can actually find the angular acceleration. How? Angular acceleration equals final angular velocity minus initial angular velocity divided by the time spent, right? Divided by this time spent. Right. So the final angular velocity is 4π rads minus initial angular velocity is 0 divided by the time spent was how much? 6 seconds, right? It was 6 seconds. So it's 2/3 phi rad per square second. Simplify the phi to get the final answer. So that is the acceleration, angular acceleration, right? And the next question, 3. It took 20 seconds for the roller coaster to come to the rest. So now this is rotating, and the question says it took 20 seconds to come to the rest, which means it slows down and comes to the rest in 20 seconds, right? So the next question is find the angular deceleration, right? So in 20 seconds it stops, and find the angular deceleration, right? So how do you find the deceleration now? The final angular velocity was this, and from this it's decelerating and stops in 20 seconds. So to find the angular deceleration, it's the same equation you had to apply, right? Alpha. So write it here. Alpha equals omega t minus omega naught divided by time, right? So alpha equals omega t is, now after 20 seconds, this is coming to the rest, which means the final velocity is 0. Initial velocity is 4 pi, and the time spent is how many seconds? In 20 seconds, right? It says it's in 20 seconds, happens in 20 seconds. So this is 4 times 5. So alpha equals, it gives a minus value, 1/5 of 5 rad per square second, right? 1/5 of 5 rad per square second of a deceleration is there, right? This is the deceleration. So minus indicates the deceleration, the reducing of the velocity, right? So this is the answer, angular deceleration, right? Next one. Find the number of rounds spun before coming to the rest. So the next question is, they are asking find the number of rotations, right? Find the number of rotations occurred before coming to the rest, right? So now at the beginning it was rotating from 0 to 4/5 rad per second in 6 seconds, right? This was happening in 6 seconds. And again from 4/5 to, this was decelerating, right? Decelerating to 0 rad per square second, right? In 20 seconds. So they are asking how many number of rotations happen before it stops, which means from here, right? මෙතන ඉඳන් ඒ කියන්නේ 4/5 rad වල ඉඳන් 0 වෙනකොට 20 seconds වලින් කොච්චර displacement එකක් වුණාද කියලා. displacement එක දහන්නේ number of rounds, or they are asking for the number of revolutions, right? Number of revolutions ගන්න අහන්නේ. So they are asking number of revolution before it stops, right? So in that case we have to apply a formula which the angular displacement includes. හැබැයි angular displacement එකයි number of revolutions we කියන්නේ දෙකක්, හරිද? So let's find the angular displacement first, and then we'll go to the number of rotations. How do you find the angular displacement? This is the best equation, omega t plus omega naught divided by 2 multiplied by time. I'm going to erase this one. So it equals omega t එක කීයද 0 මෙතනදී plus omega naught එක 4/5, and time spent is actually 20 seconds. So you have to divide this by 2 and multiply by the time, that is 20 seconds. So it's actually 45 radians, right? 45 radians of a displacement. Now this is not the revolutions, this is not the number of rounds or rotations happen. So how do you find the number of rotations or the revolutions? Number of revolutions, like one revolution is equal to 2 pi radians, right? එක revolution එකෙන් 2 pi radians. So 45 කියලා කියන්නේ revolutions කීයද කියන්න බලන්න තියෙන්නේ. So this is how we check it. So divide 45 rad of a displacement by 2 phi. එතකොට මේ තියෙන one rotation. එතකොට 45 කියලා කියන්නේ rotations කීයද කියලා බලන්න තියෙන්නේ. That is 20 revolutions, right? 20 revolutions තමයි 45 කියලා කියන්නේ. 45 is 20 revolutions. Nice. Okay. Shall we go to the next one? Uh, 21 bicycle wheel. Right. So can show the previous slide again, 20th question. This one? This one? Yes. Okay. Right. Done. Let's go to the next one. Right. Total cost is fine. It took 20 seconds. Yeah, 21. The bicycle wheel was rotating at a speed of 1200 rpm and came to rest in, there should be 5 seconds, because 55 seconds is a bit of an odd number to simplify. 5 seconds. Using a brake before applying the brakes. Find the frequency. That is easy, right? So RPM is given. You can easily find the frequency. How? RPM divided by 60 is frequency, right? RPM divided by 60. Right. So right. So frequency equals RPM divided by 60,200 divided by 60. So that will be 20 hertz, right? That will be 20 hertz. Right. That's the number of hertz frequency. Second one, find the rotational period. So the reciprocal of the frequency is period, so it's easy. Now we have frequency, the period will be the reciprocal of it, that is 60 divided by 1200. Again it's 1/20, that is 0.05 seconds, right? 0.05 seconds. That's the period. Find the angular velocity. Angular velocity is 2 phi f, isn't it? Angular velocity is omega equals 2 phi f. So you can easily find it 2 phi into 20, which is 45 rad per second, right? 45 rad per second. Right. calculate the angular deceleration. So it comes to rest in 5 seconds now, so you have to apply a equation, omega t equals omega naught plus alpha t. So if you apply this, isolating the alpha, you can find it. Final angular velocity is 0 because it comes to the rest. Initial angular velocity is 45 rad per square second plus, you have to find alpha. Happens in how many seconds? 5 seconds, isn't it? Yeah, 5 seconds. It's 5 seconds. So you'll give a minus value. 5 alpha equals 45. So 5 to this is 8. Alpha equals minus 85 rad per square second, right? 85 rad per square second is the angular deceleration, right? Next question. Find the number of rounds rotated in 5 seconds time plane, right? So in 5 seconds time plane, you have to find the number of revolutions. So before finding the number of revolutions, you have to find the angular displacement, then the revolutions. So what can you use to find the displacement? The common equation, the easy one is theta equals omega t plus omega naught divided by 2 multiplied by the time, right? So omega t is final angular velocity, that is 45, right? Plus no, sorry, the final is 0, right? Because it's coming to the rest, right? Final is 0 plus initial is 45 divided by 2, right? Divided by 2, and the time spent is given 5 seconds. 5 seconds. So that will be 25 into 5, that is 105 radians, right? That is 105 radians in displacement. So if you have to find revolutions, that you have to divide 105 by 25, right? So that is 50 revolutions, right? 50 revolutions, right? Right. So that is question number 21. Finishing. Take the notes quickly if you want. So can you send the circular motion PDF to the group? Can. Hold on a second. I think I sent it to the group before. I'll send it back. Can you pop up the group? Yes, he did, but it's not in my storage anymore. Okay. Can you pop up the group for a second? Right, thank you. Going to send it now. Circular motion is a circular. Component. Good. Sent. That's the end of the group with it. Still browsing to send. Right, shall we go to the next question? Finish. So the next question, right? 20 seconds. A rotating board. It came, right? PDF. Ah, no, it's still browsing. I don't need it's 179 kilobyte, but it's still browsing. Maybe the internet is really slow. I'm sorry for that. Right. Anyways, come to the question here. A rotating board at rest is rotated through an angle of 100 reds in 5 seconds by applying a force of 25 newtons. Right. There, I think few of the mistakes were there in this question. Now, this for the next question. We'll correct them and do the answering. So the first question says find the torque. Yeah, it's okay. We can find the torque still because its radius is given 2 meters and the force applying is 25 newtons. Right, force applying is 25 newtons. So the torque is equal to Fr as we discussed earlier, force into the radius, right? So force is 25 newtons and the radian is 2 meters. So the torque is 50 Newton meters. It's all fine, right? It's all fine. 50 Newton meters. Second question, find the moment of inertia. So to find the moment of inertia, there's not enough details given, but you can find the acceleration here if you want though. Now think of it in this way. So it says rotating board at rest is rotated through an angle of 100 reds in 5 seconds. So we can take this as the final angular velocity, right? You can think it as the final angular velocity 100 divided by 5 because it's displacement over time. And this says it starts with from the rest because that like the initial angular velocity is 0. We'll have to take it that way. So we have the final angular velocity, initial angular velocity, and the time spent. So you can take the acceleration from there. So when you have the acceleration, moment of inertia. Now the third question is actually asking find the angular acceleration. So the second question should be this. Third question should be this. Because to find the the moment of inertia, you have to find the acceleration first. So that's what we are going to do now. We're going to find the acceleration. So before finding the acceleration, omega is delta theta over t, displacement difference over time. It says 100 phi in 5 seconds of time, if I'm correct. Let's check. Yes, right. Yeah, no, 100 reds, no 5 is there. There's no 5, just 100 reds in 5 seconds, which means 20 rad per second of angular velocity is there. So this we can take as the final angular velocity. Initially 0. So you can find the acceleration by alpha equals omega t minus omega naught over t. Or the regular equation is omega t equals omega naught plus alpha t. So isolated alpha and direct going to apply it directly. So alpha equals omega t minus omega naught divided by t. Omega t is 20. Initially it was 0 and this occurred in 5 seconds of time, right? So it's 4 rad per square second of angular acceleration. Now you have the angular acceleration and the torque. So as the third question asks, find the moment of inertia. You can actually find it. How? Because we know a formula that tau equals I alpha. Now we have alpha, we have tau, we just have to find I, right? And this is how we do it. So tau is 50, right? You have to find I, and the alpha is 20, right? Alpha is 20, right? No, alpha is 4. I'm sorry. Alpha is 4 rad per square second. So I will be how much? 12.5? Yeah, 12.5. Its units are kg m square, kg meter square, right? That's I. Find the angular acceleration, you found it. Find the moment of inertia, found it. Find the final angular velocity. This we actually found it at the beginning, right? Yeah. Yes. Before finding the acceleration, we found it. So the question should be find the angular velocity first, then the angular acceleration, moment of inertia, or like torque, and then the moment of inertia. So the order is a bit different. For 1, 2, 3, and 4 would be better, right? We found the angular velocity already, right? If you want to take the notes, make it quick. Finish. Done. Nice. So let's come to the next question. Right, 23. A rupee coin is placed at a distance of 45 centimeters from the center on a horizontal turntable. Then if the velocity of the rupee coin is 2.5 meters per second, find the centripetal acceleration on the coin, right? If the velocity of the rupee coin is 2.5 meters per second, find the centripetal acceleration on the coin. So centripetal acceleration is v square over r, right? So it's v square over r. Let's find it. So as the question says, there's a table and there's a coin, right? There's a coin. So the radius is 45 centimeters of a distance, right? 45 centimeters of a distance. And the velocity of the rupee coin is 2.5 meters per second. The velocity is actually 2.5 meters per second, right? And they're asking for the centripetal acceleration, that is A equals v square over r, right? So v is 2.5 and its square divided by r is 45 over 100, because 45 is centimeters. You have to divide it by 100 to make it meters. So how much is it? Can you divide and tell me quickly with it? Diana, could you tell me the answer for this one? 2.5 square divided by 45 divided by 100. How much is it? Is it what's happening? So how do we write this? That is 1.388 into 10 to the power minus 3, right? But I got like 13.8. Are we in the same page? I got like 13.5, because you have to multiply it by like the 100 reciprocals and goes up. 2.5 square is 6.25, right? So 6.25 multiplied by 100 is 625. Divided by 45 is 13.88. So the acceleration is actually 13.88 meters per square second, right? This should be the answer, right? I think. Yes. Yeah. So the next. A ball attached to a string moves in a horizontal circle, like a horizontal circle, like this, horizontal, of radius 1.5 meters. It shows 3 rotations every 1 second, right? It shows 3 rotations every 1 second means the frequency, right? 3 rotations every 1 second. So 1 second per second, 3 rotations, right? 3 revolutions. And a ball attached to a string moves in a horizontal circle, and the radius is 1.5. Now this means 3 hertz, 3 hertz of a frequency, because frequency is how many rotations or revolutions per second. So it's 3 hertz. Radius is 1.5. Okay. What is the frequency of the ball? It's 3 hertz, easy. What is the linear velocity of the balls? Not the balls, ball. So for that you had to find the angular velocity first, then you have to convert it into linear velocity or the tangential velocity, right? So omega equals 2 phi f. So the f is 3, 2 phi into 3, that is 6 phi rad per second, right? 6 phi rad per second. And if you converted it into the linear, that is v equals r omega, and r was given 1.5 meters. Yeah, 1.5 meters. That is 1.5 meters into 6 phi, that is how much? 1.5 times 2 is 3. Okay, 3 times 3 is 9. That is 95 meters per second velocity. Like convert this into decimals. Pi decimals to convert kala tiyanna answers. Right. Frequency of the ball, linear velocity of the ball. What is the centripetal acceleration? So centripetal acceleration is v square over r, right? It's v square over r. So it's easy. You have v square, 9 phi square, and you have to divide it by the radius 1.5, and that is the acceleration. 9 square is 81 pi square, 81 pi square divided by 1.5. This should give you an answer, right? Make a balance divide kala kiyala. Final answer එක තියන්න. ඕක තමයි v square over bar. Right. හරි. ඊට පස්සේ මේක නම් ඕනේ නැහැ. මේක අපිට තියෙන ෆෝමියුලා එකක් නෙමෙයි. හැබැයි ඒක නිකන් ෆෝමියුලා එකට ඇප්ලයි කරන්න විතරයි තියෙන්නේ. මේ දීලා තියෙන වැලියුස් ටික ෆෝමියුලා එකට ඇප්ලයි කරන්න තමයි තියෙන්නේ. අපි 33 එකකින් නම් පටන් ගමු. අර ක්වෙස්චන් එක නෝට් එක දාගෙන ඉවරද? ඒක නෝට් එක දාගන්න. Right. Done. Okay. So let's go to the next one. This one. Find the moment of inertia about a vertical axis passing through the center of the system in the diagram. So now there's a vertical axis from the center of the diagram passing through the center of the system in the diagram, and they're asking for the moment of inertia from this center axis. So there are 5 of the masses, one mass here, one mass here, one mass here, and one mass here, and the side lengths are like 6 meters and 6 meters, so it's a square, right? 6 6 6 6, right? So all are 6, no 7s are there. And now it's a square, like it's a square, perfect square. So to find the moment of inertia, the total moment of inertia of the whole system, you need to have the moment of inertia of each and every mass, and you have to add them all together, right? So moment of inertia of this mass, this mass, this mass, and this mass, all together you have to add them, right? You have to add them all together, right? So we'll do that. So if we add all the moment of inertia, like it's all the same radius, because it's a square, it's all same radius and same mass. So if you find one mass and the radius, and you find the moment of inertia, and if you multiply it by 4, you'll get the total moment of inertia of the whole system, right? So let's do it. So here it's I equals mr square. So mass is 5 kilograms. You have to find the radius. How do you find the radius? So if this is 6, this is 6, this will become a diagonal, and that is the hypotenuse of the triangle. So using Pythagoras, you can find the hypotenuse of the triangle or the diagonal of the square, and half of this diagonal is the radius, right? So it's 6 square plus 6 square equals the diagonal square, and that is 2 into 6 square equals the diagonal square. So diagonal equals 6, right? 6 root 2, right, is equal to 6 root 2. So the radius equals the half of it, which is 3 root 2. Now you have the radius. So we put the radius here, 3 root 2 square of it. That will be how much? 3 square is 9. Root 2 square is 2. 9 into 2 is 18. 18 into 5 is 90. So I equals 90 there, right? I equals 90. So 4 times that is there. So the total moment of inertia is equal to 90 into 4. That is 360, right? kgm square, right? Understood it? That one is easy. Take the notes. Finish. Done? Right. Nice. Come to the next question. 25. This is a good one. Good. 25. A metal ball of mass 2 kilogram is attached to a string 50 centimeters long and moves vertically with a velocity of 20 meters per second, right? Find the tension in the string at the top, middle, and the bottom positions of the ball, right? So it's a 50 centimeter long string, 2 kilogram of a mass, and moves in a velocity of 20 meters per second. Okay, let's do, right? So it's okay, 50 centimeter long string, right? It's a 50 centimeter long string. It's a mass of 2 kilogram. And they're asking for the tensions of the rope at two of the points at X here, Y and Z. Y here and Z here. So if you think of finding the tension here, this is the theory. So here the centripetal force, right? Centripetal force applied. Here is tension because it's a string. The centripetal force is kept by tension of the rope, right? Centripetal force is kept by the tension of the rope. It's tension, right? And if you take the separate points, let's take the X point first, right? At point X, the mass is at the bottom and it's still rotating. 20 meters second of a velocity, it rotates, right? 20 meters of a 20 meters per second of a velocity, tangent velocity, it moves. So now here it's 50 centimeters, the string length, and the mass is 2 kilograms, right? Mass is 2 kilograms. Mass is 2 kilograms. This is 50 centimeters. Mass is 2 kilograms. And the velocity, linear velocity is 20 meters per second, right? It's 20 meters per second. And you're asking to find the tension. So this is something you're supposed to know. So the centripetal force is tension, and there's a centrifugal force, or the force acting outward the center, which you measure by mv square over r, right? මේක හැමතිස්සෙම rotation එකක් යනකොට center එකෙන් එළියට force එකක් තියෙනවා. You call it centrifugal force and you measure it with mv square over r. ඒක අපි mv square over r ට equal කරලා ගන්න. හරි. එතකොට මේ object එක මෙතන තියෙද්දි centrifugal force එකක් පල්ලෙහාට තියෙනවා, tension එක උඩට තියෙනවා. Apart from that, මෙන්න මෙයාගේ 2 kilogram mass එක තියෙනවානේ. අන්නේ 2 kilogram mass එකකින් පල්ලෙහාට force එකක් යනවා කොච්චරද? mg නේ. mg කියන force එකෙන් නැත්නම් මෙයාගේ weight එක කියන force එක එනවා. ඒතර forces තුනක් තියෙනවා මේ point එකේදී. මෙයා දැන් මේ rotate වෙවි යන ගමන් හොඳ. මෙහෙම යන ගමන් මෙන්න මෙතන point එකේ ඉන්නේ mv square over r. centrifugal force එක එළියට තියෙනවා. centripetal force එක ඇතුළට තියෙනවා. ආපහු weight එක පල්ලෙහාට තියෙනවා. ඒතර මෙයා උඩ යන්නෙත් නැහැ, පල්ලෙහා යන්නෙත් නැහැ. It doesn't go up or down. So this keeps in a circle without moving up or down, which means the forces at the bottom should equal to forces at the top. මේ උඩ තියෙන ඒවායි bottom එකේ තියෙන ඒවායි equal වෙනවා. So if I equal those, that says T equals mv square over r plus mg, right? මේක තමයි ආට එන equation එක. T එක equal වෙනවා mv square over r plus mg ට. පල්ලෙහාට තියෙන forces දෙක ඒක. උඩට තියෙන tension එක. මේක තමයි formula එක. මේක හදා ගන්න ඕන මුලින්. Next thing is you have to calculate it. Mass is 2 kilograms, velocity is 20 and it's square. Radius is 50 centimeters is 0.5 meters, ne? 0.5 meters. Right. So 0.5, this becomes 4. 20 square is 400. 400 into 4 is 1600 newtons plus mg is 20 newtons, right? 2 kilograms. Ne? So the tension at this point is equal to 1620, right? Newtons. 1620 newtons. Right? Tension is 1620 newtons at this point, at x. This is x. Right? So I'm going to go to the y. You understand how we found the tension at x? එතන point එකේ tension එක හොයාගත්ත විදිහ තේරුණාද? You understood it? Yes, nice, good, very good. Okay, so let's go to the y, right? Let's go to the point y. Right, point y. Point y, the string stays like this. This is 2 kilogram mass. This is 50 centimeter string. And these are the forces. Tension is acting towards the center, and centrifugal force mv square over r acting outwards the center, weight mg is acting downwards. Now this rotates like this. So now this is the thing. So now mg is acting downwards. Tension and mv square over r are like in a line and they are perpendicular to each other. So now in this case, as we discussed, if the forces are perpendicular, one doesn't affect the other. මෙයාගෙන් මෙයාට effect එකක් හරි මෙයාට effect එකක් හරි නෑ. So you have to consider only the forces in the x-axis in this case, which are T and mv square over r, and those two should be equal, because when the circular motion happens, the 2 kilogram doesn't go inward or outward. Therefore, to go in a circle, these two should be equal. So T equals mv square over r, right? T equals mv square over r. So mass is 2 kilograms, velocity is 20 and its square, radius is 0.5 meters, radius is 0.5 meters, and that will be 1600 newtons, right? So at this point, the tension is less than at the bottom, isn't it? At the bottom, at the bottom it's 1620 here, right? At the bottom it's 1620, but now it's just 1600, right? It's just 1600 now. Get it? And now we are going to find the tension at the top point, right? Going to find the tension at the top point here. Now the length of the string is 0.5 meters. Mass is still the same, 2 kilogram. Tangential velocity is 20. Everything are same. You have to find the tension anyways. Now this is T. So at this point, what are the forces acting? mv square over r is acting outwards the center, and weight is now acting downwards mg, and the tension is also there. And if this is to go in a circular motion, this mv square over r should be equal to mg plus t, because this object doesn't go up or down or inward or outward the circle, so these two should be equal. So if I equal those two, mv square over r should equal to mg plus t. So I want t, right? So tension equals mv square over r minus mg, right? Here minus mg to find it. So mv square over r is again the same, 20 square divided by 0.5. Now this is totally 1600 minus 20 is mg, that will be 1580 newtons, which means now the tension has become much more less at the top point, isn't it? At the top point, tension has become much more less. So let's say you are rotating an object in a vertical circle. You have to know at the bottom the highest tension is there, right? If you have rotated a basket with water or something, you'll understand this. At the bottom, the tension is more, tension is more. And when it comes to the middle, tension is a bit released. And when you come to the top, tension is much more released. You will feel very less of a tension to your hand. When you are rotating at the bottom, more tension, less tension, very less tension, more tension, less tension, very less tension. Likewise, you'll feel it, right? By rotating something, you'll feel it. So that's about the tension. So you want to write it from the beginning? From this one, right? Tell me when you finish. I'll turn to the next one. Finish. Yes. So put a done when you finish taking the notes. Yes, sir, done. Okay. This one. And take the notes with a good understanding how I applied it and how and why I took it that way. Just have a good understanding when you like take the notes. We finish. Done. Nice. Shall we go to the next question? Let's go to the next one. Right. 26. A student tries to move an object of mass 0.2 kilograms in a vertical circle of radius 1.5 meters. Find the minimum velocity that the ball must have at the top of the hoop to complete the revolution. That's a good question. Something to think there. A student tries to move an object of 0.2 kilograms of a weight, vertical circle of radius 1.5, right? Find the minimum velocity that the ball must have at the top of the hoop to complete the revolution. Okay. So this is what I are going to do. Yes, sir. So you are doing a rotation, right? You are doing a rotation. 0.2 kilograms of a weight, and the length of the string is 1.5 meters. This is 1.5 meters, and so you are rotating it, right? Rotating it. You are trying to rotate it, like you're trying to rotate it like this, right? Trying to rotate it like this. They ask, like, when you rotate it, this is what happens, right? You can go here at this point, right, to the top point, and then if the velocity is enough, it will go the other way and complete the rotation, right? This will go here. If the velocity is enough, it will complete the rotation. Or else, if the velocity wasn't enough, it will go to the top and it will fall down onto your head, right? So you have to have the minimum velocity to the object to not fall down onto your head, but to complete the rotation. The minimum velocity to do that, right? But a decimal amount of a difference of this velocity can drop it onto your head, right? So you have to find the minimum velocity to make the circular motion of this object, right? So this is the theory. So you have to rotate this in a velocity that it comes here to the top, right? Now it's in the top, right? And these are the forces acting on the top. You can draw it as a complete straight line. These are the forces acting. So this should move in a v velocity. So there's a weight acting downwards, mg, right? And the tension is there. Tension is there. and there's mv square over r outwards are there. So these are the forces acting, and you have to find the minimum velocity to keep the circular motion, right? Now this is the theory. So if you have to keep the circular motion complete, the forces upward and downward should be equal, and it shouldn't make the object move away from the circle or move towards the circle, right? If that is not to happen, like if the like to the object to not to go away from the circle or toward the circle, the forces outward the center and inward the center should be equal. මේක ගැලවිලා යන්න නැති වෙන්න, උඩට හරි පල්ලෙහාට හරි ගැලවිලා යන්න නැති වෙන්න, outward forces and inward forces should be equal. That's the theory, right? But we need the minimum velocity as well, right? We need the minimum velocity as well. That's the other thing. So how do you take the minimum velocity is the question, next question, right? So now think of it in this way. When this is rotating, when this is rotating, right? When you increase the velocity, mv square over r will increase, which means the force outward will increase, right? And when the force outward is increasing, the tension will also increase because it's trying to grab it outwards, increases the tension. මේ mv square over r එක වැඩි වෙනකොට මෙයාගේ outward force එක වැඩි වෙන එක මෙහෙට අදිනවා වගේ එකක්. Because of that, the tension will also increase. Hope you understand that, right? When you increase the velocity, this velocity, the outward force will be more because it's trying to grab it that way. The tension will be also more, right? එහෙම අදින්න හදනකොට tension එක වැඩි වෙනවා. So if you reduce this velocity gradually, mv square over r will be less, therefore the tension will also be less, right? Tension will also be less. So we want the minimum velocity anyway. So if you gradually reduce it, the mv square over r will be less, therefore the tension will also be less. So when you gradually reduce it at one point, mv square over r will be less, that the tension becomes zero. Try to understand that. Mv square over r becomes, when you reduce the velocity at a certain point, mv square over r is that much reduced that the tension is zero, right? When the mv square over r is reducing, tension is reducing. So at a certain point in a velocity, there will be a zero tension, right? There will be a zero tension. mv square over r එක අඩු කරන් යනකොට tension එක zero වෙන moment එකක් එනවා. There will be a moment that the tension is zero. At that point, tension is zero, mv square over r and mg are equal. So the forces upward and inward are equal, that it will continue the circle anyway. Tension එක zero වුණාට upward force එකයි downward force එකයි equal, therefore this will continue. Circle එක continue වෙනවා. But like if the velocity reduce further, velocity එක තව චුට්ටක් හරි further reduce වුණාත්, හරිද? Velocity එක තව චුට්ටක් හරි further reduce වුණාත්, ඊට වඩා චුට්ටක් හරි velocity එක reduce වුණාත්, what will happen? The mv square over r will be less, mg will be more. That means this will collapse onto your head. mv square over r එක මීට වඩා චුට්ටක් හරි වෙනවා. දැන් tension 0. තව චුට්ටක් හරි අඩු වුණොත් mv square over r එක mg වලටත් වඩා අඩු වෙනවා. That means this will collapse onto your head, right? So at this point, mv square over r should be equal to mg and tension should be 0, and that is the minimum velocity that you can complete a circle or a circular motion. The point where the tension becomes 0, becomes the minimum velocity to complete the circular motion. That's the theory, right? We have to understand that. So what do we have to do here is we have to equal mg to mv square over r, right? The theory is at the minimum velocity to complete the circle, tension should be 0, right? That's the theory. So now we have to simplify this, right? So mass is 0.2, gravitation acceleration 10. Again, the mass is 0.2. Anyways, they will cancel out. You have to find the velocity, and the radius is how much? 1.5 meters. Right? 0.2 to 0.2 will cancel out anyways. So now v square equals, if you cross multiply this, that will be 15. V square equals 15 root, right? You can convert it into surds, then 5 times 3 wagi kanti. So 15 root anyways, meters per second. So if you rotate this object in 15 meters per second of a velocity, this will complete the circle in minimum, right? This will complete the circle in minimum. You understood it? This part is important. Understood it or not? Take the notes and let me know if you understood it, because calculation is easy here. Thinking is a bit of a vast. Good, you understood it. Nice. Shiny, Genuka, you understood those? Bit of a theory was there. Shiny, yes, nice. Can you explain it again? Sure, Diana can do it. Right. So this is like the question is asking the minimum velocity to complete the circle, right? Question is asking the minimum velocity at the top to complete the revolution, right? So the minimum velocity to complete the revolution, you have to find in this way. At the top point, we have to think about what happens here. At the top point, there are few things happening. What? The weight is acting downwards, tension is acting downwards, and mv square over r is acting upwards, right? That is at the top point, right? And for a circular motion to occur, these forces outward and inward should be equal, because මේ තියෙන forces equal වුණොත් තමයි මෙහෙම ගානට circular motion එක යන්න පුළුවන් නේ. නැත්තම් මොකද වෙන්නේ? Either the object comes to the center or object goes away from the center. Get it? මේ තියෙන forces equal වුණ නැතුනොත් either it comes to the center or goes away from the center. Right? So those two forces from either side should be equal. That is one point. Right? And the other thing is, right? So I'll take it to another diagram, right? So at the top point, these are the forces mv square over r, and downward it's tension and weight mg are there. For a circular motion to occur, these forces should be equal, which means mv square over r should be equals to tension plus mg, right? But the next point is, like, when the velocity increases, the velocity factor increases, that means the object is like grabbed towards outward the center. මෙන්න මේකෙන් එළියට අදිනවා මෙහෙම. object එක එළියට අදිනවා mv square r වැඩි වෙනකොට. That is the centrifugal force. Centrifugal force එක මෙයාව එළියට අදිනවා. එතකොට tension එක මොකද වෙන්නේ? මෙහෙම අදිනකොට tension එක වැඩි වෙනවා. Tension will be increasing, right? මෙයා මෙහෙම අදිනකොට tension will be increasing. මෙහෙම අදිනකොට tension මෙතන pivot point එකකින් තද කරලා තියෙන්නේ tension එක වැඩි වෙනවා. velocity එක වැඩි වෙන්න mv square over r එක වැඩි වෙනවා. ඒ කියන්නේ force එක මේ පැත්තට තියෙන වැඩි වෙනවා. right mv square over r එකේ velocity වැඩි කරන්න. ඒ කියන්නේ අපි වැඩි velocity එකකින් දානකොට මෙයාගේ outward force එක centrifugal force එක වැඩි වෙනවා. centrifugal force එක වැඩි වෙනකොට tension එකත් වැඩි වෙනවා. right that's what happens. So we want the minimum velocity to complete the circle. ඒ කියන්නේ අපිට velocity එක පොඩ්ඩක් අඩු කරත් still this will go in a complete circle. Why? Because it just have to equal two of the forces at the either side. That's all what it has to happen, right? So now just think it in this way. I'm reducing the velocity, which means I'm reducing the force outwards, or I'm reducing the centrifugal force. And when I'm reducing the centrifugal force, the tension is also reducing because the tension is increasing when the object is grabs outward the center. නේ මේක එළියට අදිනකොට tension එක වැඩි වෙනවනේ. එතකොට velocity එක මම අඩු කරනකොට මේක එළියට අදින එක අඩු වෙනවා. ඒ කියන්නේ m square over r එක අඩු වෙනවා. ඒ කියන්නේ tension එකත් අඩු වෙනවා. That will reduce the tension and still completes the circular motion, right, with a less tension. So if I reduce further, the tension reduces further, still continues the circular motion, right, because still the forces are equal. And there will be a certain point, a certain velocity, that tension becomes zero, right? At a certain point, the tension at a certain velocity, at a certain point, at a certain velocity at this point, මෙතනින් තමයි, at a certain velocity at this point, the tension will become zero, right? Therefore, mv square over r will equal to mg. Now still the forces are equal. Upward and downward forces are still equal. This can still continue the circular motion, right? At this point, it is the minimum velocity to complete the circular motion. If the velocity was further reduced, තව දැන් මේ මෙතෙන්දී equal නේ. දැන් මෙයා තව reduce වුණොත් velocity එක තව reduce වුණොත් මෙන්න මේ centrifugal force එක තව අඩු වෙනවා. එතකොට mg එක weight එක ඊට වඩා වැඩි වෙනවා. දැන් මෙතෙන්දී tension 0 වෙලා තියෙන්නේ. හැබැයි centrifugal force and weight equal. එයා circular motion එක අරන් යනවා. හරි. further reduce වුණොත් කියන්නේ තව චුට්ටක් හරි velocity එක reduce වුණොත් mv square over r එක අඩු වෙනවා. mg එක ලොකු වෙනවා. ඒ කියන්නේ එළියට force එක අඩුයි, ඇතුළට force එක වැඩි. ඒතර මේ object එක collapse වෙනවා. හරි. එහෙනම් minimum velocity එක කියලා කියන්නේ, හරිද? minimum velocity එක කියලා කියන්නේ tension එක 0 වෙලා mg and mv square over equal වෙලාවේදී තියෙන velocity එක. right? tension එක 0 වෙලා mg and mv square over equal වෙලාවේදී තියෙන velocity එක තමයි minimum velocity එක. මීටට පොඩ්ඩක් හරි අඩුනොත් මේක collapse වෙනවා. හරි. So at this point you have to find the velocity. That's all. So v square equals rg, which is 1.5 into 10 in this case, and v equals 15 root meters per second. Understood it? Diana? Actually the calculation is simple in this one, but the understanding is the bigger part before applying it. Yes. Understood it slightly, or understood it like understood it? You understood it good? Got it. Nice. Very good. Superb. Right. Then we'll go to the next question, shall we? Yeah, we'll go to the next question. Okay. 26. A student tries to move an object. 27. We discussed this, right? 27. An object of mass 0.25 kilogram is in horizontal circular motion. It's horizontal circular motion. Huh? that it's not a vertical one, it's now a horizontal one, right? Circular motion with the help of a string 0.75 meters long. If it shows a rotational speed of 5 revolutions per second, find the tension in the string, right? So it shows a 5 revolutions per second frequency. They're asking for the tension of the string. So if it goes in a horizontal one, right? If it goes in a horizontal one, that means tension inward, centrifugal force outward, mv square r, and the weight is acting downwards, and weight doesn't have anything to do with tension and mv square over r, because they are like in two of the axes නේ. මෙයා දැන් horizontally කරකෙන්නේ tension එක ඇතුළට mv square over r එළියට. මෙන්න මේ horizontal balance එක තියන් ඉන්නේ මේ දෙන්න. මෙයාගෙන් අපිට ප්‍රශ්නයක් නැහැ. මේ දෙන්නට මෙයාගෙන් ප්‍රශ්නයක් නැහැ. නේ වෙන වෙනම axis දෙකකින්. Therefore t should equal to mv square over r නේ. Right? T should equal to mv square over r. That should be the equation at this point. හරි. මේ point එකේදී මේක තමයි equation එක වෙන්න ඕන. And they haven't given the v. Instead they have given the frequency that 5 revolutions per second happens. 5 revolutions per second means the frequency equals 5 hertz, and the string is 0.75 meters long, right? String is 0.75 meters long, and the rotation speed of the frequency is 5 hertz. So by using this 5 hertz you can find omega, right? Because we know that omega equals 2 pi f. So 2 pi into frequency is 5, that will be 10 pi rad per second, and mv square of r is also m r omega square. If you can remember, we discussed this, because v equals r omega. If we replace v with r omega, this will be the formula, m r omega square. So now we have omega. So tension should equal to m r omega square. This is the equation you should apply. And what they're asking for is find the tension of the string. Yeah, you have to find the tension of the string. So what's the mass given? Is the mass given? Yeah, 0.25 kilograms. Mass is 0.25 kilograms, right? So mass is 0.25, radius is 0.75 into omega is 10 pi, and it's square. So multiplying this, you can find the answer. Could you tell the answer, please, quickly? And I hope you understood it. That one is easier than the last one. Make a horizontal plane එක යන හින්දා අර tension එක වෙනස් වෙන්නේ කලින් වගේ. It's the same tension. Could they tell me the answer? finish 18.7 without simplifying the. Okay, so it's 18.755 is it? Yes. Okay. 880, 185.20. 185.20 newtons of a force. Good. Nice. Thank you. You understood it, right? It's easy. Hope it's easy. Not that hard, no? Can do. Right? Yes. Nice. Next one. 28. A Honda Fit car, that's my vehicle. Okay. A Honda Fit car travels in a circle path of radius 2 meters. It travels in a circle path of 2 meters of a radius. The coefficient of the static friction between the car and the wheels of the car is 0.6. Static friction is this. Calculate the maximum velocity of the car can maintain to travel the curve without skidding. Okay. So this is what it says. So the vehicle is actually running in a bend, right? I'll take this as the vehicle. This is the vehicle, right? I'll take it as a box, right? Easy. That is the vehicle. And the radius of the bend is 2 meters. This is 2 meters, right? That is 2 meters. Coefficient of the static friction mu is equal to 0.6. Okay. And they're asking maximum velocity the car can maintain to travel the curve without skidding, right? So this is what you should understand here, right? So now when this is taking a bend, what is the centripetal force acting to the center? That is one question. What is the centripetal force acting to the center? When you are taking a bend in a vehicle, what is the centripetal force acting to the center? What do you think the centripetal force acting to the center? Even looking at the details given, can tell. What is the centripetal or the force acting toward the center? Shiny. What is the force acting toward the center here? Could you tell? It's actually the friction, isn't it? It's the friction. You can't take a bend without friction, right? If there's no friction, the force toward this, the centripetal force will be gone, like the face toward the center will be gone. So you can't take the circular motion. Instead, you will go in the direction of the tangential velocity, which is skidding or slipping, right? Will slip. The vehicle will slip and will go in the linear direction instead of going the circle. So the friction is a must because friction keeps the centripetal force. So the friction is actually the centripetal force here. That is one thing to know, right? When you're taking a bend, centripetal force is provided by the friction, right? Mu r. And outward force is mv square over r. It's the centrifugal force. And these two forces should be equal to take the rotation clean or take the bend clean, right? And the weight acts downwards. In this case, like downward, like invert the plane, like it's here from this direction to down. So the weight doesn't affect the friction of mv square over r, right? So we don't have to worry about the weight in this case because it's like a horizontal plane. Bend එක ගන්න එක horizontal plane එක අපි අර vertical plane එක ගන්න bend එක ගන්න නෙමෙයි. මේක horizontal plane. So Fn m square over r විතරයි අපිට කන්සිඩර් කරන්න තියෙන weight එක තියෙන පල්ලෙහාට ඇතුළට. මේ අපි උඩින් බලන්නේ. Right. So F should equal to mv square over r. They are asking the maximum velocity to take the bend. Right. ඒ කියන්නේ ඔයා මේකේ ස්පීඩ් එකකින් ඇවිල්ලා බෙන්ඩ් එක ගන්න තියෙන පුළුවන් maximum velocity එක. ඒ කියන්නේ ඊට වඩා velocity වැඩි වුණොත් ඔයා friction එක overcome කරනවා. හරි. friction එක overcome කරනවා. friction එක overcome කරනවා කියලා කියන්නේ ඔයා මේ පැත්තට වීස් වෙනවා. skid වෙනවා. ඒ කියන්නේ ඔයා මෙහෙම එනවා හයියෙන් velocity එක වැඩි කරන මොකද්ද වැඩි වෙන්නේ? mv square over r එක වැඩි වෙනවා. හයියෙන් එනවා mv square over r එක වැඩි වෙනවා. mv square over r එක වැඩි වෙලා friction එකට වඩා mv square over r එක වැඩි වුණොත් මොකද වෙන්නේ? This will skid away. Right. මේක ගලවිලා යනවා එළියට. That will happen. ඒතර අපෙන් අහන්නේ velocity එක වැඩි කළා bend එක ගන්න පුළුවන් maximum velocity එක කීයද කියලා. ඊට වඩා වැඩි කරොත් මෙයා ගලවිලා යනවා. විස් වෙලා යනවා. skid වෙලා යනවා. Right. So we have to find it. Right. ඒතර maximum velocity එක වෙන්නේ maximum friction එකට එන්න පුළුවන් velocity එක. අපි ඒක දාලා බලමු. maximum friction එක ආයතයට ගන්න ඕන. maximum friction ගන්න කොහොමද? friction equals mu r, right? Friction equals mu r. So the mass isn't given. Actually mass is not necessary because the mass will cancel out. අපි friction එක හොයමුකෝ. friction equals mu is given 0.6. R should equal to mg because in the vehicle mg and r should be equal. So instead of r I can put mg. එතකොට 0.6 mg තමයි friction එක. එතකොට මම මෙතන apply කරනවා 0.6 mg is the friction is equal to mv square over r. And what is r? 2 meters. Right. Now what happens? M to m cancels out. Now we have 0.6 into g. G is 10. That is 6. 6 into 2 is 12. So v square equals 12. V should equal to, you can take it as 3 into 4, 2 root 3 meters per second. So this is the maximum velocity you can go. This is the maximum velocity you can go. If you go more than any like චුට්ටක් හරි මීට වඩා වැඩියෙන් ගියොත් මොකද වෙන්නේ? ඔයා friction එකට වඩා force එක එළියට තියෙන force එක වැඩි වෙලා ආව එළියට skid වෙලා යනවා. හරිද? And this is the maximum velocity you can go. මීට වඩා චුට්ටක් හරි වැඩි වුණොත් friction එකට වඩා mv square over r වැඩි වෙලා එළියට යනවා. එක්ක ඔයා මේ velocity එකෙන් යන්න ඕන bend එක ගන්න. නැත්නම් ඊට වඩා අඩු velocity එකෙන් ගන්න ඕන. ඒ හින්දා තමයි when you are taking a bend you have to slow down because if mv square over r or the centrifugal force increased more than the friction, instead of taking the bend, you go away from the bend. එළියට තමයි යන්නේ. Right. They have to slow down before taking a bend. Reason is this. More the velocity, more the centrifugal force that will throw you away from the center. Right. Take a note quickly. Understood it? That's the important part. Did you understand it? Yes, nice. Good. Take a note. Done. Nice. right? Shall we go to the next one? 29. A car of Honda Civic attains a velocity of 8 meters per second in a period of 8 seconds in a circular path of radius 600 meters and then continues to move with the same uniform velocity in the car. Okay. Find the tangential acceleration. Okay. So it says a car of Honda Civic attains a velocity of 8 meters per second in a period of 8 seconds, right? In a circular path of radius 600 meters and then continues to move with the same uniform velocity in the car. Find the tangential acceleration. Okay. So tangential acceleration you can easily find because it says car Civic attains a velocity of 8 meters per second in a period of 8 seconds. Ne? Can me 8 meters per second velocity එකක් ගන්න 8 seconds වලින් නේ. ඒකෙන් ඔයාලට ගන්න පුළුවන් tangential acceleration එක. කියන්නේ මෙන්න මෙහෙම vehicle එකක් එනවා. හරිද? 600 meter නේද bend එක? ඔව්. bend එක 600 meters එකක්. මේ ඉන්නේ car එක. මෙයා 8 seconds වලින් 0 to hero 8 meters per second. Velocity එකක් ගන්නවා 6 seconds is 8 seconds in 8 seconds of a time. 8 seconds of a time එකකදී මෙයා 0 ms minus 1 to 8 meters per second වෙනකම් velocity එක increase කරනවා. හරිද? ඒතර අපෙන් අහනවා linear acceleration එක. ඒතර මේ ටිකෙන් ගන්න පුළුවන් linear acceleration එක නේ. We put v equals u plus at, you can easily take the acceleration. Okay. How? The final velocity is 8, initially start with 0, plus you have to find the acceleration. Time taken is 8 seconds. So acceleration is actually 1 meters per square second. 1 meters per square second. Right? V equals u plus at then మనం గන්න පුළුවන්. Right, 1 meters per square second acceleration. Find the tangential acceleration. Okay. Find the tangential acceleration twice. It's the same, right? Tangential acceleration. Okay. Find the resultant acceleration. No, sorry. This should be find the angular acceleration. Right? It should be angular acceleration. So you have to find the angular acceleration as well. So we know that v equals r omega, isn't it? V equals r omega. So omega equals v over r, isn't it? Omega should equal to v over r, right? So if we simplify this, v is 8 meters per second, right? I'm sorry. They're asking for angular acceleration, right? So it's a equals r alpha. Doesn't have to go that much. They're not asking for the velocity, they're asking for tangential acceleration. So a equals r alpha. Alpha equals a over r. That's the formula, right? Alpha equals a over r. The acceleration is 1 meters per second. The radius is 6 meters. So the acceleration is this much. 1 over 600 meters per square second. No. You find the angular that per square second. Make it angular acceleration. A equals r alpha, alpha equals a over r. Right? Find the resultant acceleration as well. Now, wait up. This is angular acceleration, and this question should be not angular acceleration, it should be centripetal acceleration. Tangential acceleration, centripetal acceleration, and resultant acceleration. I'll write it 3 times. अब මෙතන තව එකක් ලියමුද? Find the centripetal අරකට අපි දැන් මේකත් හෙව්වා කියලා හිතමු angular එකත්. Centripetal acceleration is another question. I find the centripetal acceleration. Centripetal acceleration කියන්නේ දැන් අපි හෙව්වේ මේ හෙව්වේ මෙන්න මෙයාව. හරි. මම මෙතන ඇඳතින් මේක නම් vehicle එක මේ හෙව්වේ මෙන්න මෙයාව. ඒ කියන්නේ tangential acceleration. දැන් අපිට හොයන්න කියන්නේ centripetal acceleration. center එක පැත්තට තියෙන acceleration එක. හරිද? දැන් 1 ms minus 1 කියලා අපි ගත්තේ v equals u plus at දාලා tangential acceleration which is 1 ms meter per square second. මේක අපිට අතන වැදගත් නෑ. අපි යට එක හෙව්වා. හරි. අපිට අතනම වැදගත් වෙන්නේ මෙන්න මෙයාව. centripetal acceleration. මෙන්න මේ center එක පැත්තට තියෙන acceleration එක තමයි ඕන. හරි. ඒක මම a2 කියලා ගන්නවා. හරි. This is a1, this is a2. හරි. Centripetal acceleration. Centripetal acceleration එක equal වෙනවා කාටද? v square over r. So v square is anyways කීයද? 8 meters per second. එතකොට 8 square divide by 600 meters. Is it 600 meters exactly? Oh, no, 600 meters. So isn't that tangential acceleration? Yeah, tangential acceleration and centripetal acceleration. You can repeat to the part. Impression. The main A2 එක centripetal acceleration එක v square over r නේ. එතන කීයක්ද 8 square is 60 divided by 600 meter per square second. දැන් ඔයාලට accelerations දෙකක් තියෙනවා. හොඳේ. මෙයයි. Third question එකෙන් අහනවා ඔයාලට resultant acceleration එක ගැන. හරි. Find the resultant acceleration. Accelerations දෙකක් තියෙනකොට හරිද? Accelerations දෙකක් තියෙනකොට a1 and a2 කියලා accelerations දෙකක් තියෙනකොට resultant acceleration කියලා කියන්නේ මේ දෙන්නගෙම මැද්දෙන් යන acceleration. ඒ කියන්නේ මේ දෙන්න perpendicular නේ. මෙයයි මේ perpendicular නේ. ඒතර එයාව හොයන්න නම් ඔයා මේ දෙන්නට දාන්න ඕන මොකද්ද? Pythagoras. ඒතර මම මේක resultant acceleration කියලා ගත්තොත් a1 square plus a2 square should equal to a r square. Right? මෙයාගේ ස්ක්වයර් එකයි මෙයාගේ ස්ක්වයර් එකයි එකතු කරලා ස්ක්වයර් රූට් එක ගත්තා නම් resultant එක එනවා. හරි. ඒක simplify කරන්න. ඒක තේරුණාද? ඒ කියන්නේ මේකේ accelerations දෙකක් හොයලා තියෙන්නේ. එකක් tangential acceleration. හරි. මේක අනිත් එක centripetal acceleration. අන්තිමට අහන resultant acceleration එක. ඒ කියන්නේ මේ දෙන්නගේ acceleration එකේ resultant. හරිද? එතකොට මෙයාව හොයලා එයාගේ ඒ දෙන්නට Pythagoras දැම්මම ඔයාලට හම්බ වෙනවා resultant acceleration. Understood that part? Take a quick note and like try to simplify it as well. Finish. Done. Nice. Shall I go to the next one? Right. Is it the last one? No, right? There's no 30. Prius car. Just hold on for a second. Right. 30. A Prius car, mass 1000 kilogram, has a velocity of 20 meters per second. While moving, it enters a track with a slope and a hill of radius 100 meters, as shown in the figure. So this has a hill of radius 100 meters, right? Radius is 100 meters. Right. The radius of the hill is like 100 meters. Okay. Find the magnitude of the reaction force exerted by the rod on the car at point A and B. That's the first question. Point A and B වල reaction එකේ magnitude එක කීයද කියලා අහනවා. හරි. Shall we do it? So this is the vehicle, comes here and goes up and comes here. So this is 100 meters. Right. It's the vehicle. It's point A. The hill is also 100 meters. And this is point B. So let's think the object is, or the vehicle is at point A. This is point A, right? And what are the forces acting here? Weight acting downwards, mg, right? Reaction force acting upwards, right? Reaction force acting upwards. Weight acting downwards, reaction force acting upwards. What else? Now this is the centripetal force reaction, and the centrifugal force, mv square over r is acting downwards, because make a rotation එකනේ, circular motion එකනේ. මෙහෙම යනකොට centrifugal force mv square over r පල්ලෙහාට, mg පල්ලෙහාට, centripetal force එක තියෙන reaction එක උඩට. So to take this like මෙහෙම ගන්න නම් මේ දෙන්න equal වෙනවා. Rn mg plus mv square over r දෙන්න equal වෙනවා. Right? So the question is asking what? Find the magnitude of reaction. Reaction එක කීයද කියලා අහන්න. So B point, A point එකේදී reaction should equal to mv square over r plus mg, right? Plus mg. මෙතනදී mv square over r plus mg ට තමයි reaction එක equal වෙන්නේ. මේ දෙන්න උඩ එකට equal වෙන්න බෑ. So mass is 1000. Velocity is given, right? Velocity is 20 meters per second. It's 20 square divided by r. Radius is 100 plus mg is what? Mass is again 1000. G is 10. Right, it's 10,000. So this is 400. 400 into 10 is 4000, plus this is 10,000, 14,000, right? Newtons. එතකොට A point එකේදී reaction එක එනවා 14,000. ඊට පස්සේ හොයන්න ඕන B point එකේදී. B point එකෙන් මෙහෙම ගිහිල්ලා මෙතන. At this point. Right. එතන forces මොනවද එතකොට එන්නේ? පල්ලෙහාට තියෙනවා mg, right? And එළියට තියෙනවා r. ඊට පස්සේ මේක circle එකනේ. එළියට තියෙනවා මොකද්ද? mv square over r. These are the forces. And these forces should be equal to complete the circular motion, right? So if I equal them, r plus mv square over r should equal to mg. We want r, so r equals mg minus mv square over r. So we found already mv square over r 20 වලින් යන්නේ 4000, mg is 10,000, so it's 10,000 minus 4,000. That will be 6,000 newtons, right? It's 6,000 newtons. But it's right. Okay. ඒක තමයි point A and B වල reactions දෙක. You understood it? Understood it? Take a note quickly. Nice. The final answer should be 6,000. So written 600 should be 6,000. 10,000 minus 400, 4,000. Finish. Done taking notes? Finish, right? Right. I'm coming. Right. Second question of 30. What is the maximum velocity of the car must have to avoid lifting off the road while traveling to point B? Okay. Point B එකට travel කරනකොට මෙයා lift off වෙන්නේ නැති වෙන. ඒ කියන්නේ කාර් එක මෙහෙම උඩ යනවනේ. මේක කරලා තියෙන නෑ කරන්න එපා. like මෙහෙම මේ වගේ එකක යනකොට අර පාලමක් වගේ මෙහෙම අමුණාන් පස්සේ මොකද වෙන්නේ? මෙහෙම හයියෙන් ගිහිල්ලා මෙතනදී මොකද වෙන්නේ? වාහනේ උඩ යනවා. ඒක උඩ ගිහිල්ලා තමයි පල්ලෙහාට එන්නේ. හරි. එහෙනම් වාහනේ උඩ යන්නේ නැති වෙන්න යන්න ඕන මිනිමම් වෙලොසිටි එක කීයද කියලා අහන්න. ද මැක්සිමම්ද? උඩ එන්නේ නැති වෙන්න යන්න ඕන මැක්සිමම් වෙලොසිටි එක. හරිද? ඒ කියන්නේ ලිෆ්ට් වෙන එක නතර කරන්න තියෙන්න ඕන මැක්සිමම් වෙලොසිටි කීයද කියලා අහන්න. හරිද? අපි ඒක බලමු. එතකොට මෙතනනේ 100 meters the car is here. These are the values. mg acting downwards, then what else? Reaction upwards, and mv square over r is also upwards, right? mv square over r is also upwards. Right, so the equation should be r plus mv square over r should equal to mg. මේකනේ තියෙන්නේ. දැන් මේක හිතන්නකෝ what happens here now. So when you are moving in the circle, this is what happens, right? Listen to this. At this point, මෙතනදී when you are moving in the circle, there's mv square over r outward the center. mv square over r එක outward the center වැඩ කරනවා. මෙහෙම යනකොට එළියට තමයි mv square vehicle එක පොඩ්ඩක් උඩට උස්සනවා. vehicle එක උඩට උස්සනවා කියලා කියන්නේ mg වලින් එන ඉෆෙක්ට් එක. කියන්නේ mg වලින් මෙයා ප්‍රෙස් කරන් ඉන්නේ පල්ලෙහාට. mg වලින් ප්‍රෙස් කරන් ඉන්න එක අඩු වෙනවා. හරි. mg වල ප්‍රෙස් එක අඩු වෙනවා. mg තමයි රියැක්ෂන් එක හදන්නේ. mg equals to reaction. ඇයි? mg වලින් ප්‍රෙස් කරනවා ග්‍රවුන්ඩ් එක. ඒකෙන් රියැක්ෂන් එකක් එනවා. එතකොට mg ප්‍රෙස් කරන amount එක අඩු වෙනකොට රියැක්ෂන් එකත් මොනවා වෙනවද? රියැක්ෂන් එකත් අඩු වෙනවා. හරි. mg ගේ ප්‍රෙස් වෙන එක අඩු වෙනකොට රියැක්ෂන් එකත් අඩු වෙනවා. හරි. කියන්නේ mv square over r එකෙන් රියැක්ෂන් එක අඩු කරනවා. right? ඒක තමයි වෙන්නේ. mv square over r එකෙන් මෙන්න මේ රියැක්ෂන් එක අඩු කරලා දානවා. ඇයි? එයා මේ වාහනේ චුට්ටක් උඩට උස්සන්න හදනවා. එතකොට පල්ලෙහාට ප්‍රෙස් වෙන එක අඩු වෙනකොට රියැක්ෂන් එක අඩු වෙනවා. හරි. And they are asking the minimum velocity to move this vehicle without lifting up. නේද? අර වගේමයි. අර අපි කලින් ගානක් හැදී ඒකෙත් ඒ වගේම එකක් තමයි වෙන්නේ. මේකෙදිත් වෙන්නේ ඔයා velocity එක වැඩි කරන් යනකොට reaction එක අඩු වෙනවා. හරි. reaction එක වැඩි අඩු වෙනවා. අඩු වෙලා there's a certain point, there's a certain moment that reaction becomes zero. velocity එක වැඩි කරන් යනකොට reaction එක අඩු වෙනවා. අඩු වෙලා එක point එකකදී reaction එක 0 වෙනවා. reaction 0 වෙනකොට mv square over r එක equal වෙනවා mg ට. හරි. මෙතෙන්දි තාමත් මෙයා ground එකේ ඉන්නේ. හරි. දැන් reaction එක බිඳුවයි. අර මේක ground එකේ ගෑවි නොගෑවි වගේ තමයි vehicle එක දැන් තියෙන්නේ. හරි. ground එකේ ගෑවි නොගෑවි වගේ තමයි තියෙන්නේ. එන press වෙන්නේ නැහැ. හැබැයි mg and mv square over r equal. තව පොඩ්ඩක් හරි වෙලොසිටි වැඩි වුණොත් outward force එක mv² වාර එක වැඩි වෙනවා mg එක අඩු වෙනවා. ඒතර මෙයා ඉස්සෙනවා උඩට. වාහනේ මෙහෙම උඩ යනවා. හරි. මෙතනදී මෙයා වාහනේ උඩ යන්නේ. හරි. වාහනේ උඩ යන්නේ. මේක නිකන් ගෑවි නොගෑවි වගේ පොළවේ තියෙනවා. එතකොට මේ පොයින්ට් එකේදී රියැක්ෂන් එක 0. එතකොට තමයි මැක්සිමම් වෙලොසිටි එක තියෙන්නේ. හැබැයි පොළවත් ටච් වෙලා තියෙන්නේ. රයිට්. පොළව ටච් වෙලා තියෙන්නේ මැක්සිමම් වෙලොසිටි එක තියෙන්නේ මෙතනදී. ඊට වඩා පොඩ්ඩක් හරි වැඩි කළොත් mv² වාර එක වැඩි වෙනවා mg එකට වඩා. එතකොට මොකද වෙන්නේ? මෙයා පොළවෙන් එළියට ගැලවෙන්න try කරනවා. රයිට්. ඒතර එහෙනම් ඔයාට මේ වෙලාවේදී වෙලොසිටි එක හොයාගත්තා නම් ඒක තමයි යන්න පුළුවන් මැක්සිමම් වෙලොසිටි එක. ඊට වඩා වෙලොසිටි වැඩි කරොත් වාහනේ අනිවාර්යෙන් ඉස්සෙනවා. මේක ඉතින් ඕන අර කැල්කියුලේට් කරගන්න පුළුවන් ඔයාට මොකක් හරි පාලමක් මොකක් හරි අල්ලලා වාහනේ දාලා ඒ වගේ ෆුට් සයිකල් එකකින් වගේ යන්න වාහනේ කිව්තින් ඉවරයි සස්පෙන්ෂන් එහෙම විනාසයි. ෆුට් සයිකල් එකකින් වගේ ඕන නම් try එකක් දාලා බලන්න කොච්චර උඩ යනවද කියලා බලන්න. උඩ යන්නේක හොයන්න බෑ අර මිනිමම් වෙලොසිටි එක යන්න ඕන කැල්කියුලේට් කරගන්න පුළුවන් උඩ යන්න නැතුව. ඒතකොට නේ ඔයාලට දැනෙනවා අර මේ පාලම උඩින් යනවා නිකන් පා වෙනවා වගේ දැනෙනවා. ඒ වගේ රියැක්ෂන් එක අඩු වෙනවා. රියැක්ෂන් එක 0 වෙනවා ඒ වෙලාවේ. එතකොට නිකන් අර ස්පේස් එකේ ඉන්නවා වගේ ෆීලිං එකක් එකපාරට එනවා පොඩ්ඩක්. දැන් මෙතනදී මොකද වෙන්නේ? m to m cancels out. v² equals r into g. r is 100, g is 10. So that's 1000. So v² equals 1000 or 100 into 10. That is v equals here 10 root 10 meters per second. මෙන්න මේ වෙලොසිටි එකකින් ගියොත් මෙතනින් මෙයාව පොළවේ ගෑවි නොගෑවි යනවා උඩ යන්නේ නැහැ හැබැයි. ගෑවි නොගෑවි ගන්නට යනවා. right. ඕක තමයි වෙලොසිටි එක යන්න ඕන maximum. Understood it? Understood it or do you want it to explain again? ඒක තේරුණාද? Yeah. Nice. අර වගේම තමයි හොඳ. කලින් එක වගේම තමයි. Nothing much difference. Not එක දාගන්න. Finish. Finish, right? Yeah. Go to the next one. Yep. Okay. 31. Yeah. There's few more to go. Okay, 31. Find the minimum velocity that the machine must maintain in order to avoid falling down at the highest point of the rack when roller coaster is in vertical motion. Radius එක 15 kilometers. ඒ කියන්නේ මෙන්න මෙතනනේ. මෙතන ඉන්නකොට මෙයාව වැටෙන්නේ නැති වෙන්න පල්ලෙහාට මේන්ටේන් කරන්න ඕන velocity එක. ඒතර අපි අර ටිකම දාගමු ආපහු. ඒතර mg තියෙනවා පල්ලෙහාට. mv square over r එක තියෙනවා උඩට. ඊට පස්සේ දැන් මේක මේ මෙහෙමනේ යන්නේ ඔළුවෙන් යන්නේ. ඒ කියන්නේ ප්‍රෙස් වෙන්නේ මේකේ වෝල් එකේ උඩට. මේ ට්‍රැක් එකේ බෝල් එකට තමයි ප්‍රෙස් වෙන්නේ. ඒ කියන්නේ පල්ලෙහාට තියෙනවා ආපහු රියැක්ෂන් එකත්. රියැක්ෂන් එක කියන්නේ පල්ලෙහාට. මොකද සර්ෆේස් එක තියෙන්නේ මෙහෙම. මේ කියන්නේ මෙහෙම. මෙහෙම යන. මෙහෙම යනකොට වේට් එකත් පල්ලෙහාට උඩට තද වෙනවනේ. රියැක්ෂන් එකත් පල්ලෙහාට. හොඳයි. mv square over එළියට. අපෙන් අහන්නේ මිනිමම් වෙලොසිටි එක මෙයාව avoid falling වැටෙන්න ඒ කියන්නේ පල්ලෙහාට වැටෙන්නේ නැති වෙන්න. අපි මේ කතා කරන්නේ අර ටෙන්ෂන් එක වගේම තමයි. ඒතර mv square over වැඩි කරනකොට රියැක්ෂන් වැඩි වෙනවා. mv square over අඩු කරන් යනකොට රියැක්ෂන් අඩු වෙනවා. At a certain point reaction becomes 0 and mv square over r is equaling to mg. මෙන්න මේ පොයින්ට් එකේදී velocity එක ගත්තා නම් ඔයාට එනවා minimum velocity එක. So m to m cancels out. V square equals r into g. 15 meters නේ radius එක. 15 into g is 150. So that's how much? 150. Does it have any certs? මේකේ cert එකක් එනවා. බලන්න 5 into 3 5 into 2 25 into 6 නේ 25 into 6 so it's 5 root 6 meters per second, right? Meters per second. 5 root 6 meters per second. මේ velocity එකකින් ගියා නම් මෙයා වැටෙන්නේ නැහැ. වැටෙන්නේ නැතුව යන්න පුළුවන්. minimum velocity එක තමයි. ඊට වඩා පොඩ්ඩක් හරි velocity අඩු වුණොත් මේ track එක ඩුස් ගාලා මෙතන ඉඳන් පල්ලෙහාට වැටෙනවා. track එක වැටෙනවා පල්ලෙහාට. Understood it? Take the notes. Done. Nice. Next one. We're still there. A disk of radius 0.3 meter is accelerated from rest under a constant force of 100 newtons in 24 seconds. What is the angular momentum of the disk after 24 seconds? If angular velocity is 32 rads per second, in this case, find the mass of the disk. So what does the question say? A disk of radius 0.3 meters is accelerated from rest under a constant force of 100 newtons in 24 seconds. Okay. What is the angular momentum of this disk after 24 seconds? Right. Right. So shall we draw this one? So it's a disk. A constant force is applied. 100 newtons. Right. Yeah, 100 newtons of a constant force is applied. Radius is 0.3 meters. Okay, and they're asking what is the angular momentum of the disk after 24 seconds. The angular velocity is the 32 rads per second in this case. All right, in first one it takes 24 seconds, and they're asking for the angular momentum, right? Okay. Angular momentum is I omega, right? So the I isn't given. What is the angular momentum? I omega. I isn't given, so you have to, find it using the equation. So they're supposed to give the formula for the I. If it is a disk, can you guys remember the equation of angular momentum for a disk? Is supposed to be given, na? Then no, na? Natham ඒව මතක තියාගන්න ඕනේ. If it is a disk, half mr square. Right? It's half mr square. මෙන්න මේක දෙන්න ඕන. මේක දීලා තිබ්බේ නැහැ. They supposed to give it. So you have to like angular momentum එක I omega නේ. එතකොට අපිට ඒක හොයාගන්න වෙනවා. I හොයාගන්න වෙනවා. එතකොට half is the mass given. They're asking for the mass, right? This is bit under constant force of 100 newtons for 20 seconds. We can find the torque here, Fr, and Fr equals I alpha, and I we can, but we don't have the mass, so we can't directly calculate I. And even if it comes to alpha, doesn't say anything about the number of rotations or anything, so we don't know in 24 seconds what happens there. If the angular velocity is 32, that's there's a bit of like lack of details in that question, so like I'll look into it and I'll tell you if there's anything to change. So shall we go to the 35 question? Yeah, question number 35. A disk of sorry, not this one. A rotating casino table has an inertia of 25 kilogram per square meter and angular velocity of 1.5 rad per second after rotating the table, right? The moment of inertia of the table increased to 32 kilograms per square meter when the ping pong ball was applied to it. Find the new angular velocity of the table. So it's I1 omega 1 equals I2 omega 2, right? So I1 is 25 and the angular velocity is 1.5. After rotating the table, then the moment of inertia of the table increased to 32 kilograms when the ping pong ball was applied to it. Yeah, moment of inertia has increased to 32 now. They're asking the new angular velocity. So you have to simplify this. It's easy. Could you tell what is omega 2? 25 into 1.5 divided by 32. Right? Make it in conservation of moment of inertia. කියන්න බලන්න ගාන කීය දෙන්නේ කියලා. කීය දෙන්නේ 25 into 1.5 divided by 30 to 1.171 1.171 rad per second. Make a conservation of moment of inertia. I1 omega 1 equals I2 omega 2. 36. That's it. Right. 36. Find the 5 kilogram mass hangs from the end of a string that goes around a smooth pulley of mass 4 kilogram. If the radius of the pulley is 2 meters, so now there's a pulley, radius, anyway, the mass is 4 kilograms. And the radius of the pulley is 2 meters. This is 2 meters. And 5 kilogram mass hangs from the end of a string. Now there's a 5 kilogram mass here. That goes around the smooth pulley. Okay, find the inertia of the pulley. Inertia. Moment of inertia is this is a disk, so it's half mr square. The formula should be given. Usually, if it is a A-level paper, the formula should be given. I equals half mr square. Mass is 4. R is 2 and its square. It becomes 4 into 2, 8 kg m square. Right? Kg m square. This is moment of inertia of moment of inertia of the pulley. Second question, find the force acting on the pulley. It's 50 newtons, right? 5 kilograms makes it 50 newtons. 50 newtons. Second question. Third question, find the angular acceleration of the pulley. For that, you have to put tau equals I alpha. You already know I. And you have to find tau, right? Tau equals I alpha. So before that, you need tau. Tau equals Fr as well. So F is here 50 newtons. And the radius of the pulley, so 50 newtons of a force is acting here downwards. Radius is 2 meters. So that's 100 Newton meters of a torque. So now you know the torque. You can apply tau equals I alpha. So 100 equals I is 8. And you have to find alpha. Right? You have to find alpha. So alpha equals 100 over 8. What is 100 over 8 now? Divide by 4, it's 25. 25 divided by 4 is something. It's 50 over 4. 12.5, isn't it? 50 divided by, 12.5. 12.5 rad per square second. Right? Find the tangential acceleration. So if you have alpha, A equals R alpha is the equation. Radius is 2 meters. Alpha is 100 over 8. It's 25 meters per square second. Right? 25 meters per square second. Yep. So that's about it. Could you take a note? Right. So that's circular motion. So if you can understand these parts and can remember the formulas and can do the applications, then you're totally fine with circular motion. Okay. And shall we wind up for today? So the next week we can discuss another lesson of revision if you want. And the exam is scheduled on August, and there's a fight going on. We'll see about it. Anyways, doesn't matter. Like, you just have to study and continue doing the papers. And when you're good with the questions, when you're like ready with the theory and everything, hopefully that's the time you're ready to face the exam. So until you practice, like until you get the best marks, like until you get the confident, continue doing it, and when it's time, you will feel it. I can do it now, right? So don't keep working on it, and you have to improve yourself. I'm saying and recover them. And if you have any of the doubts, if you want anything to be explained again, just tell me. I'm here for you. And that's so far it. So we'll see the next week, right? See you all.